Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of object-oriented software engineering. We'll dive into key concepts like best practices of RUP software life cycle. Let's get started. Slide 1. Best practices of RUP, Rational Unified Process. Let's begin by understanding some essential best practices that guide the Rational Unified Process or RUP. These practices help in developing quality software in a systematic way. 1. Develop iteratively instead of building the entire software in one go. RUP suggests breaking the development into smaller parts called iterations. Each iteration adds some functionality and allows testing and feedback. For example, in an e-commerce application, the login module could be developed first, followed by payment and cart modules. Significance. This allows flexibility in corrections during development. 2. Manage requirements. This practice focuses on identifying and understanding what users want, and keeping track of changes in requirements as the system evolves. Example, if during development, users ask for a new wishlist feature, it should be analyzed and managed properly. 3. Use component-based architecture. Here, software is designed using components, which are self-contained parts that can be reused in other projects. Example, a payment gateway module used in multiple shopping websites. Benefit, saves time and ensures consistency. 4. Visually model software. Using UML, RUP encourages creating visual diagrams like class, sequence, and use case diagrams to simplify understanding of the system. Example, a use case diagram showing how a user interacts with an ATM system. 5. Verify software quality continuously. Testing is not just at the end but happens during every phase to find and fix issues early. Significance. Avoids costly corrections later. 6. Control changes to software. Every change to code, design, or documentation is managed properly using tools like Git to avoid conflicts. Example, version control systems help keep track of who changed what. 7. Manage risks proactively. Identifying potential risks like technology failure or budget overruns before they happen and planning solutions in advance. 8. Use iterations for feedback and improvements. Feedback from users or testers in every iteration helps to refine and improve the system. 9. Maintain proper documentation. Keeping technical and user documentation updated for future reference. Example, API documentation for developers. Slide 2. RUP Software Development Life Cycle Overview. Now, let's move on to understanding how RUP structures the software development life cycle. 1. RUP divides the development process into 4 major phases: inception, elaboration, construction, and transition. Each phase has clear goals and deliverables. 2. Each phase is iterative, meaning work is done in small cycles instead of one big block. This allows regular feedback and corrections. 3. Roles are clearly defined, like project manager, designer, developer, and tester, so everyone knows their responsibilities. 4. Disciplines or workflows run through all phases, including business modeling, requirements, design, implementation, testing, and deployment. 5. UML, Unified Modeling Language, is used to visually represent system components and how they interact. 6. Iterative and incremental development allows developers to address risks and quality concerns at each step. 7. Each phase has milestones, which are key checkpoints to evaluate progress. 8. Example, if building a banking system, in the first phase, basic requirements are gathered. Later, modules like account creation, transaction processing are developed. 9. Significance. Helps avoid sudden failures by breaking down work into manageable parts. Slide 3. RUP Software Development Life Cycle Phases explained. Let's understand the four main phases of RUP more clearly. 1. Inception phase focuses on defining the project's goals, scope, and key risks. Example, for a hospital system, identifying the need for patient registration, billing, and appointment features. 2. Elaboration phase detailed analysis of requirements, system architecture, and addressing high-risk aspects. Example, finalizing how the appointment scheduling module will interact with the database. 3. Construction phase main development phase where coding and testing of components take place. Example, actually building patient record management and billing systems. 4. Transition phase final deployment of software, user training, and fixing remaining issues. Example, training hospital staff to use the system and addressing post-deployment bugs. 5. Disciplines like design and testing are continuous, ensuring every feature is correctly implemented. 6. Feedback loops allow corrections at every step, making the development process flexible. 7. Each phase has concrete deliverables, ensuring measurable progress. 8. Significance prevents last-minute surprises and errors. Slide 4. Advantages of RUP. Advantages of RUP. 1. Iterative and incremental approach allows early testing and feedback. 2. Risk reduction. Risks are identified and resolved early. 3. Focus on quality. Regular testing ensures fewer bugs. 4. Defined roles. Clear division of work improves team efficiency. 5. UML for modeling makes system design easy to understand. 6. Effective requirement management adapts to changing user needs. 7. Component reuse reduces effort for common modules. 8. Customer involvement frequent feedback makes sure product meets expectations. 9. Better planning, milestones and documentation improve predictability. Slide 5. Disadvantages of RUP. Disadvantages of RUP. 1. Complex process, can be difficult for small teams. 2. Costly, may require specialized tools and training. 3. Steep learning curve, requires understanding of many concepts and tools. 4. Heavy documentation, consumes time and resources. 5. Time consuming, formal structure slows down fast-paced development. 6. Tool dependency, depends on tools like IBM Rational. 7. Unsuitable for small projects, overhead may outweigh benefits. 8. Requires skilled management, success relies on experienced project managers. 9. Less adaptable to rapid changes, harder to adjust when requirements change frequently, compared to agile methods. Key takeaway: RUP is powerful for large, complex software projects where structure, quality, and risk management are essential. But it may not be suitable for small or rapidly changing projects.